Bismillahirrahmanirrahim. Assalamualaikum. Okay, now we meet again for topic 5, which is time series analysis. Time series data means that the data is in a series of particular time period or interval. This time series analysis include a broad spectrum of hypotheses as well as exploratory method, with the main goal is to identifying the nature of phenomenon represented by the sequence of observation and to do forecasting, which we want to predict the future value based on the information from previous data. To meet with these goals, it requires us to obtain the pattern of observed time series data and identify as well as describe the information from the data. The time series data is a set of observation on the value that a variable takes at different time. You can have the time series data from the area of economic and finance. It also can have in meteorology and hydrology, medicine, engineering, as well as in quality control. And your time series data can be in either continuous or discrete observation. In time series analysis, it is assumed that the data consists of a systematic pattern, where these systematic patterns mean that you can usually identify the component in a set, and also random noise, which usually makes the pattern difficult to identify. This random noise represents the error. Most of the time, the random noise or the error will be filtered out in order to make the pattern or the pattern in a data set more noticeable. Actually, time series data is not a new thing to us. You may come across with this time series data. It's just that you may not know that that is a time series data. For example, when you read a column on a business, you may happen to see price movement in Kuala Lumpur Stock Exchange KLS. If you happen to run a business, actually you have created a time series data. And if you happen to see a time series data, you can see that there is a up and down information in your data. So this up and down information can help us to predict or forecast onto a future information. There are 4 types of component in time series in which it influences the pattern and contribute to the variation of time series data. So these 4 components are trend, cyclical, seasonal variation, and irregular fluctuation. It allows us to make forecast on the future data. So to illustrate these 4 time series component, this figure may help you to have a better understanding in these 4 components. Okay, first we look at trend here. Trend is the main component of time series which result from long-term effect of social, economic, and political fact. This trend may show the growth or decrease, increase or decrease in a time series over a long period of time. Example under trend is population growth, population death because of more advance in science, or increase in company sales data or network usage. Cyclical and seasonality data is a short-term pattern under time series component. Both cyclical and seasonal component have a wave-like pattern. So if I can draw the information, it will be like this. Okay, so there are a wave-like pattern. The difference between cyclical and seasonality is that the pattern in cyclical is not at a fixed interval times. For example, it not happen every 2 years, it not happen every weeks, it not happen every 6 months. That is cyclical. However, seasonal it have a fixed time data. The pattern occur almost the same every. The trend can be predicted. For example, the increase of sales for school item every year, the number of Kueh Raya book every year during Hari Raya or during Shawwal, that one is seasonal. The pattern is fixed, or you can see that the movement is similar every year. As for irregular fluctuation, okay, I'm zooming from this graph, okay, you can see that there is unpredictable movement in this pattern. You cannot predict what happened. It can occur at any time period and without any sign of warning. For example, the irregular fluctuation can be from tsunami, earthquake, flood, outbreak like COVID-19. That one is under irregular fluctuation. In this topic, we only focus on two components, which is trend component and seasonal variation. So here, we will only discuss on moving average method or smoothing process. Under moving average method, you will learn on odd data, for example, like 3 seasonal moving average, and even data, 4 season moving average. So today we will look first on even data, usually be represented by 4 quarter moving average. So look at this example, 4 quarter moving average. It can also be in 6 moving average, 8 moving average, as long as it is even data. So look at this example. The following data shows the sale of Syarikat UNA taken quarterly for 1993 to 1995. This is the information. The sales here for quarter 1 in 1983, the sales will be 130. For quarter 2 for 1993, the sales is 250 and so on. So every time you get your data, it's best for you to illustrate the information in terms of graph like this so that you can identify the pattern of the data. So we can see that there is some increasement. At certain part, it will be decrease and then increase, decrease. How are you going to calculate the moving average method for even data? I have transformed the previous data into this form, where here the first one is column for year, the second one is quarter, and the third one is the sales, the actual data from the table in the previous slide. First thing in 4 quarter moving average or even data, you have to make sure you arrange according to year. 1993, 1994, 1995. You have to make sure that the quarter that you assign here is according to the year. Okay, 1993, quarter 1, quarter 2, quarter 3, quarter 4. Followed by 1994, quarter 1, 2, 3 and 4. And then 1995, quarter 1, 2, 3 and 4. You are advised to make a space between quarter 1 and quarter 2, quarter 2 and quarter 3 and so on. There are purpose of doing this. Okay, and then you make sure that you key in the sales according to quarter and year. So the first one is 130 for quarter 1 1993, followed by 250 quarter 2 1993 and so on. Once you have finished this one, we need to create another column here. So here I create a column for total 4 quarter moving average. Okay. So how to perform this calculation for this column? What you have to do is that add the quarter 1 until quarter 4, 130 plus 250 plus the 300 plus 180. And then the value you put between quarter 2 and quarter 3. Why here? Because you want to balance the two above here and the two below here, the two value below here. You discard the first value, 130, and then you add up another 4 value below. So quarter 2 plus quarter 3 plus quarter 4 plus quarter 1 at 1994. The value you should take between value above, two value above here and two value below here. So it should be in here. So the value that I obtained is 880 for this value. So this is the purpose why we have to make a space between each quarter. So we proceed with the next one. So you discard this value. And then you add up from quarter 3, 1993 until quarter 1, 2, 3, 4. Until quarter 2, 1994. So add up these 4 values. You will obtain 930 with the calculation, and you only stop when you cannot add up the 4 value of quarter. So I have calculated all of this. So this is the information that I obtained. So the last value under total for quarter moving average is between quarter 2, 1995 and quarter 3, 1995. So the next process is you create another column for average for quarter moving average. This is my column, average for quarter. Information that you get is that you get the total here and then you divide by 4. 860 divided by 4, you get 215. 880 divided by 4, 220. Proceed until this value. So here are the information for total divided by 4 or average for quarter moving average. So you have to create another column for trend. So this is column trend value. This column trend value is also known as centered for quarter moving average. So how are you going to find this information? So the method or the step that you need to do for this one is that you add up these two values, 215 plus with 220, divide by 2. So you will get the value here. Again, so I will write up like this, 215 plus with 220 divided by 2. So you will get 217.5. So the next one, for the next value, you will do, you cut off the first value here, and then you add up 220 plus 232.5 divided by 2, and the value should be in here. So you do the calculation until you cannot add up the two value. So this is the value that I obtained. So I'll stop until here. So these two value I add up, 285 plus 295 divided by 2, and then I will get 290. So this is the last value of trend value. So I put here as TL, last trend value. So here will be T1, first trend value. So here I show you the information on how you get 215. It should be 860 divided by 4. So it goes for 880 divided by 4, you will get 220. So next is you have to find your seasonal variation. So you have to create another column for seasonal variation. So here is a column for seasonal variation is Y divided by T. So where you get your Y? This is your Y. And your T is here. So recall back, your Y is your actual data. And your T is your trend value. So how you going to conduct this one? You look at the sales that have the trend value. Sale with trend value. So which one has trend for its sales? So here you can look here. So if you look here, the third quarter 1993 has the trend value. So and draw like this. Okay. So make sure you do sale divided by trend. 300 divided by 217.5. Make sure your trend value is in 4 decimal places. So my first seasonal value is 1.3793. So proceed until you finish for the last trend value. Next part, you have to tabulate seasonal variation into another form of table. So what is the value that need to be in here? So what is this value represent from? From the seasonal variation. You look at the first value here. Third quarter 1993. This is your third quarter 1993. So the value here is 1.3793. This one. So this I have included in this column. Okay, the next one is 0.7956 is for quarter 1993. So you just fill in the value of seasonal variation in this table. Okay, I put star here to represent that there is no value for first quarter and second quarter 1993 and third quarter and fourth quarter 1994. The next part is to estimate the seasonal indices. So the first step is you have to find the total for each quarter. So you add up these two values and find the value for this first quarter. So the first quarter total value will be 1.274. So proceed with second quarter, third quarter, and fourth quarter. So next part is to find the average for each quarter. So how to find this average is that you have to total divide by the number of data in each quarter. So in here, the first quarter, you only have two value of seasonal variation. So you will get 0.637. So proceed for second quarter, third quarter, and fourth quarter. So here is the value of second quarter, third quarter, and fourth quarter. So once you have obtained this average value for each quarter, you need to sum up all the average. So if you look here, the total average is 4.0083. Okay, 0.637 plus with 1.2065 plus 1.3726 plus with 0.76, 0.7922. So if you look at this total average, the value is above 4. Okay, your quarter is 4. However, your total average is above 4. So we will do adjustment if the total average is above or below number of quarters. So number of quarter here is 4 and now the total average is above that one. So create another row for adjustment. So to do the adjustment, it should be number of quarter divided by total average. So here we have a number of quarter is 4 and the total average is 4.0083. So the adjustment that we get from this seasonal variation is 0.9980. After you find adjustment, then you can proceed with finding seasonal indices. So this is another row, which is row for seasonal index or seasonal indices. So you have to find for each quarter. This is the formula to find your seasonal indices. So the first quarter seasonal indices will be 0.6357, where you find average for first quarter times with adjustment. You proceed with second quarter, 1.2065 times with 0.9980, and then for third quarter, 1.3726 times with 0.9980, and for fourth quarter will be 0.7922 times with 0.9980. So this is the value that I obtained for second, third, and fourth quarter seasonal index. Okay, from this information, you can interpret the value of seasonal indices. If your value is above 1, so we can say that there is an increase of sale. Why I'm using sale? Because this is involving sales. If value lower than 1, so we can say that there is a decrease in sale. So from the seasonal indices value, we can say that quarter 1 and quarter 4 has a decrease of sales, while second and third quarter have an increase of sales. So for example, I want to interpret for first quarter seasonal indices. So the value that I obtained before this previously is 0.6357. So you multiply with 100. It will be 63.57%. So this means that the sale of Syarikat UNA decreased by 36.43% every first quarter of each year. Why suddenly I get 36.43%? Because you need to minus 100 with 63.57 because there is a decrease. Now, if you want to interpret for seasonal index second quarter, the value that I obtained previously is 1.2040. And when I multiply with 100, it will be 120.4%. So this means that the sales of Syarikat UNA increased by 20.4% every second quarter of each year. So since the value is above 100, so it should be 120.4 minus with 100. So to do the forecasting, you need to follow this 3-step method. So for forecasting, the first step that you need to do is to find the trend variation value, known as TVV. So the formula for TVV is the last trend value minus with the first trend value divided by number of trend minus 1. The next step is to find the projected trend value, your T. The trend value is denoted as T. Remember, this is your trend value. It been denoted by capital letter of T. So the formula will be the last trend value plus with TVV, the value that you obtain from here, times with T. So your T here represent the trend after the last trend value. The last step in forecasting is to forecast using projected trend value and seasonal indices. You have obtained the trend value in second step here, and you have obtained the seasonal indices from this table. So the formula will be value of respective period equals to trend value for respective period over seasonal index for respective period. Now, let's say we need to project trend value for first quarter 1996. So let's get back to this table. By using this step, we able to estimate the value of sales for first quarter 1996. So now, the first one is to find TVV. So TVV is this formula. So you look at the trend column. So this is the trend column. So I have denoted earlier, this one will be T1, the first trend value, and this one will be the last trend value. So N here is number of trends. So how many data in this trend column? 1, 2, 3, 4, 5, 6, 7, 8. So your N should be 8. So I have calculated the value of TVV. I extract the information from this column trend, into this formula. So here is the last trend value, 290. The first trend value is 217.5. And your number of data in trend column is 8. So you will get 10.3571. So the next part is to find the projected trend values. So I just write here as X, T. I want to find this one. Now, the first small t start exactly after the last trend value. So this is your last trend value. So the first t will be here. T equals to 1. And then here for fourth quarter 1995 will be t equals to 2. First quarter 1996, the small t will equals to 3. So this is how I write for second step. The last trend value is 290. Your TVV you obtain from here. And then your small t you extract from this information. So once you have find all the information, we go to step number 3, which is forecast the sales for first quarter 1996 using this formula. So projected trend value period, this is projected trend value period that you obtain from here. And then you times with seasonal indices. So you have 4 seasonal indices, the first quarter, second quarter, third quarter, and fourth quarter. So which seasonal indices that you need to use? So now you look back at the question, at the information that we need to retrieve. You have to look for the first quarter of 1996. We use seasonal index of first quarter. Your expected sales for first quarter 1996 will be 204.1050. So make sure if it is in RM000,